if P of A is equal to 0.7, P of B is equal to 0.5, and P of A union B whole complement is equal to 0.1, then P of A given B is option A 3 by 7, option B 3 by 5, option C 5 by 7, and option D 1. P of P of A union B whole complement is given as 0.1, P of A given as 0.7, and P of B is given as 0.5. This is a given data. We have to find P of A given B. P of A given B is P of A intersection B divided by P of B. But we don't have P of A intersection B. We know that P of A union B is equal to P of A plus P of B minus P of A intersection B. From this we can get P of A intersection B is equal to P of A, this is not bar, P of A plus P of B minus P of A union B. Here P of A is given as 0.7 plus P of B is given as 0.5 minus P of A union B. Here P of A union B whole complement is given as 0.1. So P of A union B will be 1 minus P of A union B whole complement, which is nothing but 1 minus 0.1. So here we'll be getting P of A union B as 0.9. So let us substitute P of A union B here, 0.9. So if we simplify this, this is 1.2 minus 0.9. So which is 0.3. So we got P of A intersection B as P of 0.3. So now let us substitute this P of A intersection B here in P of A given B. So here this is 0.3 divided by P of B. P of B is given as 0.5. So 0.5. 0.3 by 0.5, which is 3 by 5. So here correct option is option B. Consider a collection of infinite cards of 4 different colors: blue, green, red, and yellow. Find the number of different subcollections of at most 5 cards. Option A 56, option B 125, option C 126, and option D none of these. A subcollection of K cards is nothing but a non-negative integral solution of the equation x1 plus x2 x3 plus x4 is equal to K. Here this equation represents the subcollection of K cards where x1 denotes the number of cards of first color, that is blue, and x2 represents the number of cards of second color, that is green, and x3 represents the number of cards of third color, that is red, and x4 represents the number of cards of color yellow. So number of subcollections is nothing but number of solutions for this number of non-negative integral solutions for this equation. So here xi should be greater than or equal to 0. So our required solution would be x1 plus x2 plus x3 plus x4 is equal to 0. Here the question is number of different subcollections of at most 5 cards. So here at most 5 cards means K may be 0 or 1 or 2 or 3 or 4 or 4 up to 5. So our solution is plus number of solutions for this equation plus number of solutions for this equation is equal to 1 plus x1 plus x2 plus x3 plus x4 is equal to 2 plus x1 plus x2 plus x3 plus x4 is equal to 3 plus x1 plus x2 plus x3 plus x4 is equal to 4 plus x1 plus x2 plus x3 plus x4 is equal to 5. So number of solutions for this equation, for this equation, for this equation, we have to find the number of solutions for each of these equations, and we have to add the all solutions. So that will be our required answer. So if we see this equation, this is nothing but number of solutions is nothing but number of ways of arranging, number of ways of arranging are similar things into n different boxes, which is given by n plus r minus 1 cr. So here for this equation, n is equal to 4, r is equal to 0. So number of solutions for this equation is nothing but n plus r, 4 plus r, 0 minus 1 c 0, which is nothing but 1. So for this equation, n is equal to for this equation n is equal to 4, that is number of distinct boxes x1, x2, x3, and r is equal to r similar things 2's, r is equal to 2, that means here similar thing is 1, 2 is nothing but 1 plus 1. So here r is equal to 2, number of solutions is equal to n plus 1, n plus r minus 1 cr. So n plus 4 plus 2 minus 1 c2, and for this 4 plus 3 minus 1 c3, and for this 4 plus 4 minus 1 c4, and for this one 4 plus 5 minus 1 c5. So these are the solutions for these equations. So if we simplify this, so our solution would be required number of different subcollections is equal to, here first one is 3c0, this is 4 plus 4 minus 1 3c0, which is nothing but 1, plus this one 4 this is 4 plus 2 6 minus 1 5c2 plus, and this one is 6c3 plus this one 4 plus 4 8 minus 1 7c4 plus this is 9 minus 1 8c5. This is the required solution. 5 plus 1 plus 5c2 is nothing but 5 into 4 divided by 2 into 1, which is nothing but 10, plus 6c3 is nothing but 6 into 5 into 4 by 3 into 2 into 1, so which is 20, plus 7c4 is nothing but 7c3, so 7c3 is 7 into 6 into 5 by 3 into 2 into 1, so which is 35, and last one is 8c5 is nothing but 8c3, 8 into 7 into 6 by 3 into 2 into 1, 7 8s are 56. So this is the required solution. Here we forgot to include this one, the number of solutions for this one. For this one, n is 4, 1 r is 1, so number of solutions would be n plus, that is 4 plus 1 minus 1 c1, which is nothing but 4c1, which is 4. So we have to add that one also. We have forgot this equation. We have to include this one also. So here plus 4 would be there, plus 4c not 4c1 plus 4c1. So it will be included here, plus 4, this is 4, this is plus 1. So if we solve this one, we will be getting 126, which is option C.